Hello guys, I'm Laksharma and today we are going to talk about the solid liquid equilibrium, and the most common case is of ice turning into water. So let's talk about that. Most of you already know well that what is the melting point of ice and what is the freezing point of water. It's the same. At 0 degree the ice melts and the water turns to ice, that you have been taught at school. But we have done it in an open system, like the melting process is done when you keep it in the room, and that's an open system. There's a whole volume, there can be nothing constant. Okay, the volume is continuously increasing, decreasing whenever the gate is opening, and the amount of heat, internal energy is also increasing, decreasing. But what will happen if we do the same thing in a closed container? Let's get introduced to some basic terms first. First is isolated system. What is it? That you isolate a system basically, so there's no heat leakage to the surroundings and no work is done, means you cannot change the volume of this system. The shape you see, this room, you cannot change the volume by deforming it, and there's no change in volume. As you all know the work formula, which is in thermodynamics, W equals Q minus W, heat minus work done. This is the total. Oh hell no. Wait. Sorry, mistake. This is internal energy actually. Okay. My bad, sorry. So yeah, the total internal energy formula is Q heat minus W work. The work is P into V. P into change in volume. P is what? P is pressure here, okay? So pressure into volume. But the change in volume, as we have talked here, the body is rigid, there's no work done, no change in volume. The change in volume is 0. So there the net work done is 0. Okay, so this gets eliminated and the only thing left is U equals to Q. So the total internal energy depends only on the heat present inside it. Now what we are gonna talk about is that there is an isolated system, there is heat inside the internal energy, and the ice is absorbing it and melting continuously. The ice has melted semi, and you can see the water molecules will have a higher kinetic energy due to faster motion, and the ice will have lower kinetic energy. Ice has semi melted, water is formed, and now what will happen? You can see this is the system, and now the heat is a little used. It was used here, but I am showing you here that we had x joules and the y joules are used by the ice to form water. Okay, so after some time you will notice that there is no change in volume of either ice or water, means you can observe it for days and you will hope that the ice melts someday, but it will not because there is no leakage. The system has attained equilibrium. What is it? That when the ice got the heat energy, it turned to water, and what you will notice that water in contact to ice will become ice. When at molecular level the water touched the ice, it will lose its energy to the colder surface of ice, and the energy will be absorbed by the molecules of ice. Sorry, the H2O molecules are of both water and ice. So basically I am saying that the bonds of ice will absorb the energy and tend to break free to water form. Okay, what is happening that? Yeah, so what you will notice is this is ice, okay, and the water is here, it come here to the surface, eventually touched it. The water will come here at the surface and eventually it will stick to it. Okay, now in a closed system, in an isolated system, there is no leakage, so you can't get energy from anywhere for free. Okay, this is not an open system, the energy remains constant inside, so what you are giving you have to return. The energy is taken into ice. It has a higher temperature obviously because it is in water form, and it becomes ice when there's a little lower temperature, a little lower energy. The higher temperature, when you stick to it, this ice will absorb its energy. This devil ice will absorb its energy, and this will get that it will lose a lot of energy. And what will happen? Its kinetic energy will be reduced too much, its motion will be negligible. It will eventually be, it is vibrating like now, like this, and when the energy is lost, it will vibrate like this. Okay, so the bond energy, you can say, of hydrogen bonds will dominate over the kinetic energy, which has now turned low of the water, and now it will freeze again to ice because there's no enough energy to break the bonds for this water. It has lost its energy.